Hi, my name is Daniel Verner, and my project involves Niagara Bottling's gallon line in Ontario, California. Little background on the subject. Niagara only has one gallon line, as mentioned already, in Ontario, and it performs two kinds of operations. It does retail ready and 6-packs that you would buy at Costco or another similar chain. The retail ready is individually sold, and it's a very manual process. The bottles are taken off the line manually and stacked on pallets. When this retail ready operation is done, stacking becomes a huge bottleneck. In the 6-packs, the packaging of those bottles is not the bottleneck, but stacking definitely is. Throughput goes down from 68% of theoretical maximum to 25% based on historical information. And this is a problem because they're sold out during the summer, so every lost bottle in throughput is lost net profit. So the problem statement, as alluded to earlier, is not having enough throughput. And there's several factors that lead into this. One is significant downtime at lunches and breaks because all workers take their breaks and lunch at the same time. The facility layout is fairly inefficient, which we'll get to later. Inefficient skill set utilization, not using the workers for the tasks that they're best at. Safety hazards in that this is a manual process. The bottles are 8.5 pounds, moving those all day long, a lot of bending and twisting, and that poses some problems. And then labor costs. This isn't as much of an issue. Throughput is definitely the priority, but if labor costs can be reduced, that's advantageous as well. So as far as going about solving this problem, we went through the DMAIC process. The first step was define. So we looked at just kind of observed the process, what's going wrong, and recorded those observations. Then measure, we did time studies. We measured 3 different variables that we'll get into on the next slide. Analyze, we looked at, okay, what changes would work best in the current environment. Use simulation to decide how many workers would be optimal for the process. We use queuing theory to decide how much improvement could be made from moving the workers down the line. A lot of economic analysis was performed to quantify how much the changes would translate into increased profitability. And we qualified ideas with management, especially regarding the incentive plan, which we'll talk about later. So improve, we implemented the ideas right away. And then control, we wanted to quantify how much was actually improved and compare the different methods of improvement to see how much their relative effect was. So the results of the time studies. 3 main factors we looked at. The differences in throughput between workers. There were significant differences. Workers ranged from anywhere from 5 minutes to complete a pallet to 11 minutes. There were also differences between layers. So the bottom layer took significantly longer than the top layer. This makes sense because the workers had to bend over more to stack the bottles at that layer. And finally, differences between workers working individually and together. So it only took 42% more time on average for workers to stack the bottles individually compared to when they were stacking them together. You would think it would be 100% more time. But the reality is when they were working together, they often talked with each other a lot. They would slow down to the pace of the slower worker to keep a rhythm going. When they needed to put a new sheet of cardboard on, that was a task that only really required one person, so during that period of time, it wasn't really advantageous to have 2 people. So all in all, this seems to indicate that it would be better to have one worker work at each station. Simulation study, this is kind of just a visual of what our final simulation looked like. We modeled breakdowns on the line, but mainly we were focused on how many workers should we have to make this process optimal. Going from 3 workers to 4 workers yielded a 5% improvement in productivity, which we'll get to on the next page. But that extra worker only costed $187 in labor, and this is per shift numbers. So clearly there's greater benefit in having that one worker there, even though his utilization won't be that high. So there really should be 4 workers. And also in the simulation, we were trying to decide whether the priority of those workers would make a difference, whether having the fastest worker in the front or the fastest worker in the back would make a difference. Didn't turn out to make a difference, so that doesn't really matter. As far as ergonomic goes, management brought huge safety concerns with this process to my attention when I started working on it. Because it's a manual process and they're lifting heavy bottles. Bottles are about 8.5 pounds all day long. A lot of twisting, bending that would like to be reduced or eliminated if possible. The best way we decided to do this would be through these special pallet jacks you can see in the picture. What these do is you start out at the height that's comfortable for the worker, and as more weight is stacked on, the pallet moves down to keep the height that the worker is stacking at consistent. Based on time studies of comparing the time it takes to complete the bottom layer to the top layer, we estimate that productivity of the workers can be improved by 8.2% by having these pallet systems. And the payback period is 32 to 64 shifts. This is based on reduced labor costs from increased productivity. But besides just economic benefits, there are significant safety benefits as well, which can lead to less chance of lawsuits and overall better worker satisfaction. So this is the current facility layout. As you can see, 6 workers at a time stacking, 2 workers at the cardboard station. The Iron Man is kind of a humorous way of showing that they're faster workers. But in any case, 2 workers work at each station, and as we've mentioned earlier, that's a problem. We only want 1 worker working at each station. Also, there's not a very long queue that the bottles come off the line before the workers stack them. So if we increase this queue, as you can see, there's space down the line. This would allow the workers, it would help even out variations in speed that the bottles are coming off the line and speed that the workers are able to stack them. So this is the new layout. As you can see, we moved them down the line. We also gave each worker 2 pallets because when they complete 1 pallet, that way they can start right on the next one instead of having to wait for the forklift driver to get there. And yeah, keep the fastest workers there for stacking. Make sure, and the other workers should be moved to another part of the facility where they can be better utilized. So the incentive plan, this was another proposition that was made. Originally it was considered to pay each worker per pallet. There's a couple problems with that. 1, it would be difficult to keep track of how many pallets each worker did. 2, there would be safety and quality issues because there may be too much of an incentive to work fast, which would reduce the incentive to deal with bottles that were improperly manufactured. And if they're working faster, this could pose safety hazards as well. And cooperation. Sometimes it really does make sense for workers to help another worker with his pallet. If they're out of pallets, out of supplies, the forklift driver is behind, whatever. Sometimes it makes sense for them to work together, and this would not be incentivized if they were paid individually. Instead, it would be better to pay workers as a group, which still provides an incentive for productivity, but not as much, so that quality won't suffer and safety won't suffer. But it also promotes teamwork and accountability because they are working as a team, and it would be much easier to record how many pallets the whole group did over the course of the day. Strategic scheduling. So as mentioned earlier, one of the main sources of downtime is workers all taking their break and lunches at the same time. This I propose as the best way to have them go about their breaks and lunch, having them take them in pairs. Obviously, it would be more efficient to have them take it one at a time. You have less people off the line at a time, but I think it would be beneficial to, have them take their best friend, go on break with their best friend or whatever to, that'll be more enjoyable. So, anyways, the green represents break, the blue represents lunch, and the yellow represents flexibility. So, the workers 1 and 2 should go on their break at 2:30. But if the line shuts down at 2:30, all the other workers should go on their break at the same time because they're not going to have much to do over that period of time. So that kind of would help even out times when the workers are down and when the machines are down. So the results, after implementing all the changes except for the incentive plan and the new pallets, throughput increased 50%. Niagara was very happy. This had total bottom line impact of $2,700 per shift. Most of it came through throughput as suspected, but a significant amount came through saved labor costs as well. As far as what changes contributed the most to this improvement, ironically, two of the changes were very easy to see based on the data and very easy to implement as well. Having one worker per station and 2 stations per worker. This increased throughput significantly. But strategic scheduling, ergonomics, and having a longer queue also had an impact as well.